This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. Now we're going to take a look at one more example of a mini-proof. In this question we're asked, in the diagram, we're told that BD is parallel to CE and DF is parallel to EG. But unlike the last question where we were just asked to prove that two lines are parallel, in this question we're asked to prove that the length of AC times the length of FG is equal to the length of AG times the length of BC. So the length of AC times the length of FG is equal to AG times the length of BC. So how do we go about proving this? Well, first we'll do our exact same steps. We will write down what we're given. So we're given BD parallel to CE. So BD parallel to CE. Let's just mark that with a couple arrows. These two lines are parallel. We're also given DF is parallel to EG. So that is these two lines down here are also parallel. So we're asked to prove that AC times FG is equal to AG times BC. So we start our proof by noticing that AC times FG is equal to AG times BC could be written as AC divided by BC is equal to AG divided by FG. And I can just show that more clearly over here. So we're told that AC times FG is equal to AG times BC. So if we divide both sides of this equation by the length FG and the length BC, so on both sides, what we see on the left is our FG on the bottom cancels with an FG on top. And on the right hand side, a BC on the top cancels with a BC on the bottom. So we're just left with this instead, AC on the top on the left and a BC on the bottom is equal to an AG on top divided by an FG on the bottom, which is what we have over here. So going back over here, the reason we do this is because our theorem 12 to do with parallel lines in triangles lets us write things in a ratio like this. So instead of looking for a multiplication like this, let's try and see if we can find a way of proving this ratio instead. So from what we were given, BD is parallel to CE. So that is in our top triangle up here. In this triangle, ACE. So this top triangle first. Let's just highlight that in. This triangle up here. In this triangle, we're told that BD is parallel to CE. So that means we can use our theorems again, but we're going to look in now this time at the whole length AC divided by its bottom piece BC is equal to AE, the whole length, divided by the bottom piece DE. Next, if we look at the second piece of information, we were told DF is parallel to EG DF is parallel to EG. So if we now look at this bottom triangle down here in blue, what we see is, using the same rule, if we do the whole side, AE, divided by the bottom piece, DE, that will be equal to the whole length of our other side, so AG, divided by the bottom piece of that side, FG. And just like in our previous example, we have this common term in these two equations. We have AE divided by DE here, and we have AE divided by DE here. So what does that mean? That means we have a link between this part of this equation and the second part of this equation, so we can set those two red boxes equal to each other. Because if A is equal to B and B is equal to C, both of these things imply that A is equal to B is equal to C, so we have A is equal to C. So that means that AC over BC is equal to AG over FG. And if we look carefully at this ratio equality here, that's what we rewrote our original problem as up here. So if we just cross multiply to get back to what the question wants us to prove, we have AC times FG is equal to AG times BC, and that is just gotten by cross multiplying these terms here. And then we've proven what was asked to be proved, so we just finish with our Q, E, D as always.